this video, we'll walk through a practical aspect of creating a scalable, optimized skill tree. We'll load all the tree's textures from soft object references in a data table and then asynchronously batch load them only when they need to be seen. So we'll start here in our content browser, going down to the MISC data folder and opening up our S skill tree node struct. And remember, this is the struct which represents a skill or a node. So it needs to have all of the information that the skill might have and all of the information that the node might care about. So we're going to add several new variables. The first one's display name, and it's going to be a text. This is the name of the skill that will show to the user. We'll also have a couple different descriptions, a flavor description and a technical description. We'll have an icon, and we're going to make this a texture 2D soft object reference. So not an object reference, but a soft object reference. We're also going to add another icon, call it picture, and make that the same, a texture 2D soft object reference. The reason we're using soft object references instead of regular object references is for scalability. Because we're designing a system that could have hundreds or thousands of nodes, if we were to use regular object references and then reference all of them in the data table, they would all be loaded all the time, which just isn't scalable. This way they're only going to be loaded when the skill tree is opened. We'll add another variable, we'll call it effect, and we'll add a final variable, we'll call it cost, and we'll make that an integer. For the effect, we're going to make a class. So we'll come over here to the content browser, right click on Skill Tree Pro, add a new folder, we'll call it Skill Effects, right click, Blueprint class, make an actor, call it Blueprint Skill Effect, BP Skill Effect. Come back over here to the skill tree node, and we're going to set it to BP Skill Effect Soft Class Reference. Let's also go over to default values and make the cost default to 1 so that every skill in the game costs 1 to train by default. So now our skill struct is finished. We can close that. And I've created an icon subfolder and imported a few icons. For those of you who are curious, this is one website, iconfinder.com. There are many websites like this where you can get free icons. Some of them have a limit, some don't. When you download from them, just make sure that you make the settings transparent so they have a transparent background, and I've found that a white foreground with a transparent background looks the best. You don't want too much detail and you don't want a lot of thin lines. That usually doesn't look very good for an icon or for UI. And we can go into MISC data and open up the data table, and we can see all the new fields for each skill. The only fields that will show on our skill tree node widget will be the display name and the icon. The flavor name and technical description and picture are for the details widget, which we'll do later, and the effect and cost are for the gameplay. And so now in the skill tree, we'll just make the skills unique with their information by setting the display name and the icons. And now that we've given each skill in our game a display name and an icon, we can implement the functionality to extract this information from the data table and put it into the node widget when we're generating the nodes and adding them to the skill tree. So we'll close the data table. So now we'll open up our WBP skill tree node and we'll add some variables. Skill tree UI, and this is going to be WBP skill tree object reference. So it's a reference to the skill tree widget that we're adding these to. And we're going to make that instance editable expose on spawn. And we'll also add node DT name, node data table name. So this is the name in the data for the data table row, not the user facing name. And we'll make that a name variable, and we'll also make it instance editable expose on spawn, compile. And now if we open up our WBP skill tree widget, we can right click on this and go to refresh nodes, and we see those exposed variables that we just created. So in the skill tree UI, we want to get a reference to self, and for the node DT name, we want to get node. It's this variable from here all the way at the bottom of the list, get node. And now we'll go back to our content browser, to the MISC data folder, and in the iSkillTreePC component interface, just like we created a getTreeInfo function, we're going to create a getNodeInfo function. Add that to the same category, and we'll add more outputs to this later, but for now we only need the data table. Data table object reference, compile. And now if we come back to our skill tree node blueprint, on construct, we can get player controller, get component by class, BPC skill tree PC, get node info message. Now we're outputting that data table. So we're going to get data table row, and the row name is going to be this node DT name. We're going to break to sSkillTreeNode, and for our text here, we didn't give it a name. We'll go back to designer and we'll just call it text. For our text here, we'll set the text to this display name. We can comment this. We're not going to do the same with the icon because we need to load it from a soft object reference. We could load it here, but the problem with loading it here is, like we said, we might have hundreds or thousands of these nodes in our skill tree. So then every time we construct the skill tree, or every time we open the skill tree, it will run this functionality that many times. So it'll be more efficient to batch this functionality over in the skill tree. We'll async load all the nodes at once and then update the icons in the nodes once they're loaded. And the other thing we need to do is come to the content browser, components, our skill tree PC component, go down to interfaces, internal, get node info, and we need to input that variable. So we'll create it and set it. DT underscore skill tree, compile, and we can close this, and we can close the interface. So now we're going to create a system for asynchronously loading all of the node texture soft references and then assigning them to the proper nodes. So in our skill tree widget, we're going to go to the event graph, and we're going to add a new event, and we'll call it load node textures. And in the generate nodes function, we'll call it after we add all of our nodes recursively. We're going to create a new variable which will store the nodes and their icons in a map. So we'll call that node icon map. We'll add it to the node generation category. It'll be a WPP skill tree node object reference and a texture 2D soft object reference. And we'll control drag that in, get the values, run a click in the graph, run a for loop, and on the loop we'll async load, and we'll create another variable. We'll call it node textures, and this one is going to be an object array. Compile, drag it in, add, and we'll add on the loop. And if the length of the node textures equals the length of the node icon map, then we know all of the textures have been loaded. So we'll create a function called node textures loaded, and we'll add it to procedural tree generation category. Call it on true. And we can comment this real quickly. Have all been loaded. And load textures from soft object references. And in the node textures loaded function, we'll do a sequence, and we'll get that node icon map values, do a for each loop, resolve the soft reference. This is dangerous to use if you don't know what you're doing because you are assuring the blueprint that it is loaded into the game when you use this. It will cause a crash if it's not. In this instance, it's safe to use because we're just adding a potential null reference to an array that we're using for cosmetic display. And if there's no texture there, then it just won't show anything. If this is valid, we're going to create a local variable and call it node textures ordered. and it can be a hard object array. And we'll drag it in and add this resolved reference to the array. And what this little bit does is it orders the textures. Now we're going to set all the node's brushes to those ordered textures. Let's put the node textures in the node generation category here. Drag in the node icon map, keys, for each loop, and in that node icon map, we'll find, and if this is valid soft object reference, let's make another local variable, call it textures to load, make it an int, and set its default value to -1. We'll add 1 and change the name to texture to load. And now in that node textures ordered array, we can get which texture we need to load. And we'll cast that to a texture 2D. And now over in our skill tree node blueprint, we'll add a function, call it texture loaded, compile, and we will input texture 2D. Compile, and back in the skill tree, now we can call that node, because remember it's getting the key of the node icon map. Drag it all the way over here and call that new function, texture loaded. And we can pass in that texture 2D that we just loaded. And what this bit of code is doing is ensuring that the textures get loaded to their correct node, even if some of the data table entries have no texture. Some of the entries might be blank in the data table. So we'll comment this. And we'll comment this. And let's add a pin. And since we're done loading all of the node textures here, and this is not a local variable, which will not get clear, when we're done loading, we can just clear that out here. And so now we'll go over to the texture loaded function that we just created. And all we need to do here is drag in the icon and set brush from texture. And we'll also set brush tint color. Split this, set it to white, compile, and you might have made the same mistake I did in the WBP skill tree widget. Come down to the load node textures event and make sure that this async load is on complete. And lastly, in the skill tree's add node branching function, to make this node icon map actually mean something, when we're creating the nodes and adding them to the skill tree, we'll also populate this variable. So from the data table, get data table row, get the node, break to sSkillTree node, expand, and now we can add to the node icon map, add from the icon, not the picture, and bring in that local node variable, and we can collapse this again. And now if we fire up the skill tree, we see that we have the text and the icons associated with each skill. Now one thing we'll notice is that the icons are a bit too big. A quick fix for that is in the skill tree node widget, we can go over to the designer, to the icon, and under render transform, set the scale to something like 0.8.8. Now you can see it's more within the bounds of the background. We'll have a better system for controlling this in the future from the component, where we'll have all of our controls. But for now, this will do. Now if we fire it up, we see it's looking quite nice. So now we have a system in place where nodes can associate with a particular skill in a scalable way and show that information to the user. In the next video, we'll improve the procedural generation to give ourselves more options for how our tree generates, to have a lot more control over the final look and feel.